everyone, welcome back to another video of Daily LeetCode Challenge Streak series. And in today's video, we have a LeetCode medium question that says minimum falling path sum. Now let's see what the question says. Given an n by n array of integers matrix, return the minimum sum of any falling path through the matrix. A falling path starts at any element in the first row and chooses the element in the next row that is either directly below or diagonally left or right. Specifically, the next element from the position row or column will be row plus 1, column minus 1, row plus 1, column, row plus 1, column minus 1. Now, what does the question say? It means that you're supposed to return the path that returns the minimum of all the elements in the path. That returns the minimum of all the elements in the path. That is nothing but minimum falling path sum. Now, what can we do? They didn't give us any specific starting point or ending point. We can traverse through any number of elements and return the best path. Return the best minimum path. Now, what can we do? What can we do in such scenarios? But remember that you can either go diagonally left or diagonally right, or straight up, vertically up or downwards, as in it's just down. Okay. Now, what can you do? If you are at position 1, you can either go to 6 or 5 or 4. Now, after that, if you come back to 5, then you can either move to 7 or 8 or 9. Now, after traversing through the whole thing, after traversing through all the elements, you are supposed to return the minimum sum of paths of all the paths that you have covered. Now, how can we solve this question? Yesterday we've discussed that to return any best possibilities like minimum or maximum, or return distinct number of ways. For such type of questions, we are supposed to apply recursion. Okay, we are supposed to apply recursion for such questions. What did I tell you yesterday? You are supposed to take all the elements in the form of indexes. You are supposed to take all the elements in form of indexes. Now, let's put this question in a different way. Let's assume that we are starting if there are n rows and m columns, okay, n rows and m columns, let's assume that we'll be starting at the nth row, and going till the 0th row. It doesn't matter. You're just supposed to return the smallest sum path in the end, minimum sum path in the end. So it doesn't matter if you start from up or down. In the end, you're only supposed to return the one with the minimum path. So assume that we will start from the nth row and go till the 0th row. What observation can we make out of this? If we are going from nth row to the 0th row, then we will be stopping the function. What will be the base case if we are going from nth row to 0th row? We will be stopping the loop. Our base condition is that when we are traversing and when we reach n is equals to 0, we'll be returning that particular element. To add to the sum. Okay, and later adding the minimum value or getting whatever it is, we will do it in the end. So if we start from n minus 1th row, assuming that there are 0 to n minus 1 rows, if it's n, then it's 1 to n. If it starts from 0, then it is n minus 1th row. Now, if we start from n minus 1th row, you will be going to the 0th row. And when you reach this, you will have to stop. Now, what other base cases can we think of? Now, while traversing, in the question it is said that you can either move upwards or diagonally upwards, left or right. So it's only one column this side or one column this side, or within the same column. Now, it might happen sometimes that if you are at 7, your possible ways to go to are 6, 5. but this one is out of bound, but this one is out of bound. So you have to make sure that your m value, okay, that your m value is not less than 0. So if the columns start from 0, 1 and 2, you have to make sure that your column value is not less than 0. Likewise, if you are at 9 and if you want to go upwards, then you'll go to 4 and 5. You can't go to this value because again this is also out of bound. So you should also check that the value you are at should not exceed m value. Okay, so if you are considering I and j values, I as row and j as column, then this j value, the column, when you are iterating, when you are starting from this particular element, you are supposed to make sure that this j value is always greater than 0 and also always less than m. M is the number of columns that are present. Now, how do we write this? Now, f of I comma j will be the function in which we will have base cases. Base case is nothing but the stopping condition. That is, it's either the destination or it's out of bound cases. Now, we've already talked about the out of bound cases or the destination. Destination is nothing but 0. Destination is nothing but 0. So, if j is less than 0, if in case we encounter something that is less than 0 or we encounter something that is greater than m, what will we return? We will return int max. Now always remember, when we are solving minimum, we are trying to find minimum of something, you are supposed to return int max for out of boundary cases. Okay, likewise, if you are solving a maximum sum, if you are trying to find maximum of something, you are supposed to return int min. Now why is that? Now if you are supposed to return max of something and you are comparing an out of bound thing, an out of bound would be int min and the higher end would be an element like 8. Now you are supposed to return 8. Now you are supposed to return a realistic value that is present and is maximum. So out of bound cannot be considered. So what is the actual value that can be considered? It is 8. But if you will consider int max for the max value only, then what will be the max of 8 and int max be? It will be int max. So for out of boundary cases, you should always consider the opposite boundary extreme cases. We were seeing that j is less than 0, j less than m, then we will return int max. Now, what was the second case? If we reach the last row, which is the 0th row, we will be returning that particular value. So, if I equals to 0, we will be returning array of 0 because the I value is 0 and whatever is the m value, the j value, as in whatever column it is in, we will return that along with the row value. Now, next, we have written the base condition. What is the next step that we are supposed to do? We are supposed to see where an element can traverse to. So, in this particular case, where can the element traverse to? It can traverse in 3 particular directions. Now, it's either upwards. Now, assuming that we are moving from below to upwards, we are writing it as upwards. If you want to solve from 0th to n-1, then you will be moving downwards, left down and right down. Okay. Now, up. If it's up, what you're doing? You're taking the value in that particular element. Now, if you're moving upwards, what is happening? The row gets reduced by 1, but it is the same column. So, it is ARR of I minus 1 comma j plus you're calling the function again. Okay, you're calling the function again to move upwards, which is I minus 1 comma j, to move upwards again. Now, what is the next case? That you're taking? Left diagonal. Okay, if it's left diagonal, what are you doing? Left diagonal as in, if you are at this point, you are going to this point. Assuming this is jth column. What does this column become? This becomes j minus 1 and this becomes j plus 1. And when you're also moving upwards, you see that a row is getting decreased from n minus 1. This becomes n minus 2. So you see that the row is decreasing. So the row becomes I minus 1 and in this case also I minus 1. So for left diagonal, the value that we take, first we'll take the value we are at, and we are moving to the left diagonal, which is I minus 1 comma j minus 1. Likewise, for right diagonal, where are we moving? We are taking that element for addition, I minus 1 of j, and then we are moving to, where are we moving? We are moving to the right. So I minus 1 comma j plus 1, because column is increased when you move from left to right. Now, what is the last step? What is the last step that we are doing? We are checking the the minimum of all the values. We are checking the minimum of all the values in the end, because we are supposed to return the minimum path. So if you take here, now you are checking from this, if this is the minimum path, if this is the minimum path, if this is the minimum path. Like if you are at 8 now, if you are at 8, you are checking if 8 plus 4 will give you the minimum value, or 8 plus 5 will give you the minimum value, or 8 plus 6 will give you the minimum value. So what are you returning? You will be returning minimum of up one, left diagonal and right diagonal. What will happen because of this? Because of this, the time limit, because of the recursion, will be exceeded. Okay, the time limit will be exceeded. Why will it be exceeded? Since from one given element we are checking 3 paths. Okay, we are traversing to 3 different ways. For every element, the number of paths that we'll be taking is 3 power n. 3 power n is exponential and is so high that the code will not run. Okay, the code will not run. Now, how can we make this better? Like instead of moving to every path and checking every time. So if you were to go here, then it will always come back here and check the value. For this, every time it will check with 3 elements and come back. Now it will check with 3 elements and come back. So every time it will be a hassle. What can we do instead? Instead, we can take a DP array. Of matrix of size n by m and store the minimum path. So if you are here and if this is a matrix, and if you are here and if you are going here, now from here to here, whatever is the sum will be stored in that particular index position. So instead of calling the same function and again for the values to perform the same function, you will directly retrieve the value from this DP array by storing. So whatever sum it is there to move from one position to one position, that sum will be stored in those index values. So this thing, instead of returning DP, instead of writing if I equal to 0, return ARR of 0 and 0j, we will directly be writing DP of, for every given DP of 0j, since we are directly returning ARR of 0j, like whatever the sum is. So in DP of 0 array, since we are directly returning whatever element is there, so in this array also, the element will hold its exact row value. So here the value will be ARR of 0j for this thing. Okay. Why will it be that? Since we are already returning this value for every element in I, this will be that in DP of 0j. Now what are we doing here? We have up, left and diagonal. Since we have up, left and diagonal, now how will we store our DP of ij value? Instead of returning min of this thing, we will store the minimum of these values in the value of DP of ij. And rest all the values will be same. So instead of sending just I value and j value, we will also be sending ARR's value and the DP array, so that every time we can keep updating it here. Now also, if we already have the DP of ij value computed, like say we came across a matrix element, this element, and this has already been computed to 2. If this has already been computed to 2 and we came across this again, so what are we doing before? We are initializing all the DP array elements to 1, such that whenever we compute that value, we will be replacing that -1 value with whatever value we got in the end. Whatever value we got in the end. So after getting whatever value we got in the end, and if we encounter the same value again, instead of computing the whole thing again, we will directly be fetching the element from this thing. So every time before we compute, we have to check if dp of ij is not equal to minus 1. You have to check if dp of ij is not equal to minus 1. If it is not equal, then you will directly return dp of ij here itself. But if the value is minus 1, then you should do the computation value and store the dp of ij value and return the minimum value in the end. Now, what will be the time complexity of this thing? What will be the time complexity of this thing? Since we are iterating over all the elements like O of n, okay, of size n, if the matrices rows and columns are of the same size, which is n by n, since it is of the same size, the time complexity would be O of n square to go across all the elements and to traverse. Now, what would the space complexity be? Space complexity, since we are storing a DP array of n by n elements, since it's n only, the space complexity would be O of n by n. Okay? Okay, now let's quickly code this up. Let's first finish our helper function. So it'll be def helper, and let's take the self method because it is given here. So self, and we'll be sending a row, a column for the DP array to compute, and then the length of the for the column, number of columns in the matrix, and the actual matrix, and the DP array. Now, what is the base condition? One of the base conditions is to see that there is no out of bound. So what is the out of bound case here? The out of bound is to make sure that the j value is not greater than m and not less than 0. Okay, so if j is less than 0 and j greater than or is equals to m, if that is the case, then we will directly return system.max size, which is we will be returning the max value, which is the out of bound. Next, what is the second base case? It is the destination. What is our destination here? The ith row is equal to 0 will be our destination. So if I equals to 0, if we are at the ith position, what are we doing? We are just returning whatever element is there in the particular row. Okay, so return matrix of, since it's 0th row, we'll be returning whatever whatever column it is, we will be returning that. Next, what are we checking? When I explained it to you earlier, we are checking that our DP array should have -1 values while initialization. Now, if it is not -1, it means that the value has already been computed. So if DP of I and j is not equal to -1, it means that the value exists. So we'll directly return dp of I and j. Next, what if otherwise? What if otherwise? It means that the dp ij value is not computed. So we'll either go upwards or left diagonal or right diagonal. So up is equals to matrix of ij plus, now we will be calling this whole function once again. So self dot helper of, now what will happen to the row? Row will decrease since we are going. And what will happen to the column? If we are just moving upwards, there is no change in the column, so it will remain as it is. Now it is the number of rows that we are passing, then matrix and dp. Next, what is our next thing? The left dia. We'll just write left diag, and then what will happen? We will take the value matrix of I j, then what will happen? Plus self dot helper of, now one row, and then since we are going left, the column number will also decrease. Next, m comma matrix comma dp. Next, what are we doing? Next, we are traversing to the right and getting the value. So matrix of I j, okay, plus self dot helper of, what are we doing? We are increasing our column. So row will decrease, column will increase, same m, matrix and dp. Okay, now in the end, what are we checking? We are checking for the minimum value of these three. We are checking for minimum value of these three and storing it in dp of ij. Okay, so minimum of up comma minimum of left diag comma right diagonal. Okay, now we'll be returning dp of ij in the end. This is our helper function. Now let's finish our main function. What are we doing in the main function? Let's first extract our length. Let's first extract our row matrix. Then column is length of matrix of 0. Next, what are we checking? Now we have to see that if the number of rows or number of columns in any given input is 1, then we will directly return because we have no paths to explore. If we have only 2, 1, 3 given, we don't have any paths to explore. So it's just the element that is given. So if n equals to 1 or m equals to 1, we'll be returning, what will we be returning? We will be returning min of matrix of 0. Okay, so whatever is the minimum, we will be returning that. So it could be this, it could be this, it could, if it's 2, 1, 3, then this is the minimum. So we'll be returning this. Matrix of 0 meaning matrix of the 0th row. Okay, 0th row is 1. Now if it's only one column given like 2, 6 and 7, this is the only column that is there. So what will we be returning? We will be returning 2. Okay, next let's call the helper function. Now before calling the helper function, we need to have a dp array. So let's initialize our dp array to -1. Okay, so -1 for j in range m. So for m rows and for m columns and n rows, for I in range n. Okay, next what are we doing? Now let's initialize a value answer to system dot max size. For this system to be used, we have to import something called import sys. Now if you import this library, that is only when you will be able to get the maximum value or minimum value. Why are we using this? I told you earlier that whenever we have to compare it with the minimum value, you need to compare it with the maximum value for you to get the minimum value out of it. Okay, now next we will be starting with n minus 1th row. We will be starting with n minus 1th row and we'll be moving upwards. Now we will start with 7 first. We'll explore all the paths. We will come back to 8 and explore all the paths. We'll come back to 9 and explore all the paths and get the minimum. Now while starting from 7 or 8 or 9, you can see that we are going column wise. Okay, so column 1 first, so column 2 and column 3, but we are starting with n minus 1th row in all the cases. Okay, so for that reason, we will be looping over the column length. So for I in range m, the answer is nothing but what? Okay, let's take this as mini. Let's store this as answer, because whatever we get out of this function as a minimum value, like if you are starting from 7, after iterating, whatever we get from 7 will be stored in the answer. Now if this answer is less than the minimum value which is already initialized, then the answer value will be updated to the minimum value. And same goes with 8. After getting 7 and 8, whichever value is the minimum, that value will be replaced. So the answer is equal to this function. So self dot helper of, what is the row that we are starting with? It is n minus 1th row. So n minus 1th row. Then since we are whatever, okay, it's not I here, it's j, for j in range m, because j is like the row reference in the helper function, so it's j. So whatever column we are at, that particular column we are sending here. Okay, next m is the number of rows here, number of columns here, and then matrix and the dp array that we initialized here we are sending. Now in the end, what are we doing? We are updating our mini value to the min of mini and answer. We are comparing and seeing which one is small. In the end, we'll be returning mini. Okay, now let's quickly run the code. Let's submit this. Thank you guys.